What if the sun exploded at exactly 800 a.m. tomorrow morning? Not in a billion years, not in a science fiction film, but tomorrow, while you're eating breakfast and checking your messages. Scientists have run the numbers, and the answer is a precise minute by minute sequence that most people get completely wrong. The explosion itself would not kill you. What kills you arrives in stages, each one more catastrophic than the last, and the order of those stages will genuinely surprise you. To understand why, you have to treat this like a real event with a real clock running. The sun sits roughly 93 million miles away, and that distance is not just a number. It is a delay, a buffer between the explosion and its consequences reaching you. Every effect travels at a different speed, which means every effect arrives at a different time. Some give you seconds to react, others give you 8 minutes, and some you would never see coming at all. The sun is not the kind of star that goes supernova, and that distinction actually matters here. Stars that explode in those massive galaxy visible blasts are several times more massive than our sun. Our star will eventually swell into a red giant, then quietly shed its outer layers into space. That's the real ending, and it's nothing like an explosion. So for this thought experiment, we're using a different scenario. A sudden, catastrophic release of energy from the sun's core. Think of it as every process that keeps the sun stable failing at once. The physics of what reaches Earth stays grounded in real science, even if the trigger is hypothetical. The light, the radiation, the shockwave, all of it behaves exactly as the laws of physics demand. That's what makes this scenario worth taking seriously because the sequence of events is terrifyingly precise. The moment the sun tears itself apart, you are completely unaware it has happened. Nothing reaches you yet because nothing travels faster than light, and light needs time. From the sun's surface to your eyes is roughly 93 million miles of empty, silent space. At the speed of light, that crossing takes exactly 8 minutes and 20 seconds. So for those 8 minutes, the sun still looks perfectly normal hanging in the sky. Birds are singing, coffee is brewing, traffic is moving through every city on Earth. Whatever you were doing at that moment, you keep doing it. No alarm sounds, no tremor moves through the ground beneath your feet. The universe has already made its decision. But the news hasn't arrived yet. Every living thing on Earth is borrowing time it doesn't know it has. 8 minutes of borrowed light, borrowed warmth, borrowed ordinary life ticking down to zero. One moment the sky is blue, and the next moment it simply isn't. There's no explosion, no flash, no warning sound that something has gone catastrophically wrong. The blue drains out of the atmosphere the way color drains from a screen when the power cuts. People standing outside would stop mid-sentence, looking up at a sky that has turned a deep, impossible black. Stars would appear instantly, thousands of them, sharp and cold in what was daylight seconds before. Your eyes would struggle to adjust because nothing in human evolution prepared them for this. The temperature wouldn't drop yet, not for hours, because the air around you still holds the warmth of a normal morning. But your body would know something is wrong before your mind could name it. A cold, instinctive dread, the kind that lives below language, would move through every person on the sunlit side of Earth. The same silent question at exactly the same moment. The same silent question at exactly the same moment. The light is gone, but something far worse is already moving through space toward us. When a star dies violently, it doesn't just go dark, it erupts, sending a shockwave of superheated plasma and radiation outward in every direction. That wall of energy is now traveling at roughly 3 million miles per hour, and it's aimed directly at Earth. At that speed, the shockwave covers the distance between the sun and us in about 17 hours. 17 hours sounds like time, but there's almost nothing useful you can do with it. The radiation burst hits first, arriving at the speed of light, frying satellites and stripping electrons from the upper atmosphere within minutes. GPS goes silent, power grids begin to fail, and the sky starts to glow with colors it was never meant to show. Then the plasma wall arrives, and it doesn't just damage the atmosphere. It begins to compress and tear it apart layer by layer. The moment the sun goes dark, every government on Earth already knows what is coming. Scientists had tracked the expansion, the dimming, the final warning signs for weeks before the end. But knowing a shockwave is 48 hours away doesn't make 48 hours feel like enough time. Power grids begin failing almost immediately because solar infrastructure drops offline without the source it was built around. Backup systems kick in, but they weren't designed to carry the entire civilized world on their own. Grocery stores empty within hours, not because the food is gone, but because people are terrified and moving on instinct. Governments broadcast shelter instructions that almost no shelter on Earth could actually fulfill. Some people drive toward coastlines, toward mountains, toward anywhere that feels like distance from something. Others stay exactly where they are and hold the people they love. The internet somehow stays partially alive. A last shared space where 8 billion people watch the same clock run down. And in laboratories and bunkers, a small number of scientists do the only thing they know how to do. They keep recording data right up until there's nothing left to record. The shockwave doesn't arrive quietly. It hits Earth like a wall of charged plasma moving at millions of miles per hour. In the first seconds, every satellite in orbit gets a pulse of electromagnetic energy beyond anything we've measured. Ground-based power grids collapse almost simultaneously because the induced current has nowhere safe to go. The magnetosphere, Earth's invisible shield, gets compressed on the sunward side and stretched violently on the other. It holds for a moment, and then it fails, peeling back like foil in a fire. Without that shield, the full force of ionizing radiation reaches the surface in minutes. Exposed skin burns, not from heat, but from the raw energy of particles moving near the speed of light. The upper atmosphere begins to strip away, molecule by molecule, driven off by the relentless pressure of the expanding solar front. What remains is thinner, hotter, and no longer capable of filtering what comes next. The planet is still here, but it's been opened up, like a wound that won't close. The shockwave passes and then the silence begins. A silence measured not in seconds, but in centuries. Within days of losing the sun, surface temperatures start their long, irreversible fall toward the void. The oceans don't freeze overnight, but they begin a slow and patient march towards solid ice. Within a year, average surface temperatures would plunge well below negative 100 degrees Fahrenheit. Deep ocean hydrothermal vents might shelter microbial life for a while, clinging to heat from Earth's own core. But every other ecosystem, every food chain, every web of life built on sunlight, collapses without a single warning shot. The atmosphere itself begins to snow out as gases freeze and drift to the ground like ash. Earth doesn't die in the explosion. It dies in the quiet that follows, in the long, lightless years of a world that simply runs out of warmth. The blast was never the ending. It was only the moment the clock started.